page is this?
130.
Page 130,
Yeah.
number 35? And what is the equation?
Y equals 5 cosine parentheses 3x minus pi over 4.
Okay, are we good to go with that? Okay, I need your attention up here, please. You cannot do this problem until you get this 3 that's inside the parentheses. You need to factor that and take it on the outside of the parentheses. If you are factoring it, you are basically dividing by 3. You're pulling it out. Because remember, to distribute it, you're multiplying when you distribute. Factoring it out is the opposite, so you're going to divide it out. So we are going to write this equation as y equals 5 cosine, get the 3 on the outside, and then the x, because if I divide that by 3, it goes away. 3 divided by 3 is 1, x, minus, you have to do pi over 4 divided by 3, which really is pi over 4 times 1/3. Right? Isn't multiplying by 1/3 the same thing as dividing by 3?
Yeah.
Yeah. Okay, so it ends up being pi over 12 inside the parentheses. Any questions on that step? Okay, then we are going to graph 5 cosine 3x first and apply the phase shift last. So the amplitude is 5. The period is 2 pi divided by 3, which you're going to leave as 2 pi over 3 because it doesn't divide in there evenly. Okay? The period is always 2 pi divided by that number, if there is a number there. So 2 pi over 3. Which is basically 2/3. What's half of 2/3? Can you do that in your head? Half of 2/3 is 1/3. If you can't do it in your head, then you have to do 2/3 times 1/2. You're taking a half of it, you're multiplying by 1/2. Equals 1/3. Or we should know if 1/3 plus 1/3 equals 2/3, then half of 2/3 is 1/3. So pi over 3. Then we're taking a half of 1/3. And if you don't know what that is, some people are really good at it and they already know, you would have to do 1/3 times 1/2. When I say a half of 1/3, what does the word of in math mean? Multiplication. And so what is 1/3 times 1/2? 1/6. So this number right here is pi over 6. Then you can either add these two together to get the third one. You'd have to get a common denominator. Or you could go 1/6. This is basically 1/6. 2/6. 2/6 is the same as 1/3. This one would be 3/6, which is the same as what? 1/2. So this is pi over 2. And this one would be 4/6. Is 4/6 the same as 2/3? Yes. So is everybody okay with getting that axis labeled? And this is just work off on the side on scratch paper or wherever you want to put it, but keep it organized. Okay, keep it organized someplace. And I'm going to do a few in the negatives. This would be negative pi over 6, and then negative pi over 3. This is going to amp up to 5, right? Go as high as 5, and down as low as negative 5. I'm just going to put that up here as 5. Well, I suppose I could go 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. And it is sine wave or cosine wave? Cosine. Does that start at the midline or does that start up above?
Up below.
Up above. Lightly sketch it in. So that much you should know already. We learned all of that before we started this shifting stuff. Any questions on that much? Now the phase shift. The phase shift goes in the opposite sign that you see. So the phase shift is going to go pi over 12 towards the positive. So to the right. Goes in the opposite direction of the sign that you see. Now the hard part is this isn't in 12ths. That's the really hard part, okay? So we have to do a lot of adding and subtracting, getting common denominators with fractions. And we're going to start with this point right here. It's going to go pi over 12 units this way. Well, pi over 12 is half of pi over 6. Because if I multiply by 1/2, I get pi over 12. So that point's going to go right there. Here, this point is going to have to move this way. So I'm going to do pi over 6 plus pi over 12, or 1/6 plus 1/12. This is really 2/12. 2/12 plus 1/12 is 3/12, which reduces to 1/4. Okay? You have to have those numbers on the bottom, on the axis. If you don't show me that you know what those fractions are, you'll be marked wrong. The graph will be marked wrong. You have to have those numbers correct. Okay. This point right here is going to go this way. 1/3 plus 1/12. Well, 1/3 is 4/12. Plus 1/12 is 5/12. So 5/12 pi. 5 pi over 12. It's going to go there. 1/2 plus 1/12. Well, this is 6/12 plus 1/12 is 7/12. And that's this one. I like drawing the little arrows. It just kind of helps me keep my stuff organized, but you don't have to. And then 2/3 plus pi 1/12. Multiply by 4, so that is 8/12 plus 1/12 is 9/12, which is 3/4. you have to show one complete cycle, or one complete period. And with the cosine wave, this is one complete cycle, from here to here. Any questions on that? That's probably about the hardest one you'll get, where none of the fraction, where you have to do a lot of fraction work, none of the fractions really jive together, and you have to pull out an awkward number up here. You know, we have to divide 1/4 by 3, that's a little awkward. So it's probably about as hard as they will get. Any other ones?
34.
Which one?
34.
34? Can I erase this? Does everybody have it? Because I don't want to switch boards. Okay, number 34, what is its step?
Sine 1/2, and then x plus pi over
1/2 times the quantity of
Yeah, x
X.
plus 1/4.
plus
1/4.
1/4 or pi over 4?
Pi.
Pi over 4. So the nice thing is this 1/2 is already outside of the parentheses, so I don't have to pull that out. So that means you can just get started. The amplitude is 1. The period is 2 pi divided by 1/2, which is a flip and multiply problem. So 2 divided by 1/2 is really what? 4. You know, that question really is asking you how many 1/2s fit into 2, right? When you say 2 divided by 1/2, how many 1/2s fit into 2? 4 of them. So 4 pi. And the phase shift is towards the negatives. So that would be to the left. So let's go ahead and draw the first graph very lightly and apply the shift at the end. Period is 4 pi, so I'm going to put 4 pi. Half of that is 2 pi, and then 1 pi, 2 pi, 3 pi. And amplitude is 1 and -1. Sine wave. Sine wave starts where at? 0. Yep, at the midpoint. Everybody should know how to do that much, for sure. Because that will be on the test as well, just graphing ones like that. Pardon me?
Just a regular one?
Just regular ones with amplitude and period change and
Like on the
midline
test,
change.
you want us to put the regular one, like what it normally looks like?
Mhm. Yep, because that helps me know what you're thinking. I like to give partial credit, and if I can see that, then I know how, you made it halfway through the problem, then I can give you half credit, okay? If you